When we are talking about interest rates, unless we specify otherwise, we always talk about some sort of annual rate. But the trouble is, not all the time the interest rates that we're going to see are based on annual rates. For example, you have a car loan, and typically these have monthly payments. Hence, interest accrues monthly. That means at the end of each month, once the balance is paid off, uh, 1 month of interest is charged to the remaining balance. But you will see that in almost all cases, interest is quoted on some sort of annual convention. There are two conventions. One is called the annual percentage rate, short APR. This basically is the periodic interest rate multiplied by the number of periods in a year. For example, let's say we're talking about a monthly payment loan. And frequency, or how many periods of this sort are in a year? Well, we have 12. We have 12 months in a year. So if the period interest rate is 1%, that means for this example loan, at the end of each month, once the payment is made, 1% interest will be charged to the remaining balance. Then APR is going to be 12 times the period interest rate. So in this case, 12%. In many cases, you will be quoted APR directly. Then you find period interest rate as APR divided by frequency. Let's say you have a credit card that says they are going to charge you 18% APR on daily balances. So what is our frequency? We're not going to worry about leap years. So we have 365 days a year. So that's our frequency. So if you wanted to calculate the period interest rate, that's going to be 18% divided by 365 if interest is accruing daily. Now, if you're talking about one single loan, that APR is all you need to know. For example, if your mortgage has 6% APR, and we know that this is monthly, then each month you're going to pay 6% divided by 12, which is 0.5% interest. If we're talking about one loan, that's all you need to know. But sometimes you do need to make comparisons of loans that are quoted as APRs, but they have different frequency. Let's use an example. Let's say you have a semi-annual annual loan, which means uh, 2 periods a year. That's what semi-annual means. You make 2 payments a year, and APR is 20%. Does that mean that you are going to pay 20% interest in 1 year? The answer is actually no. Period interest rate is easy to calculate. It's APR divided by the frequency. In this case, 20%, and we have 2 semi-annual periods in a year, so 10%. Then that means on this loan, every 6 months, you are going to be charged 10% interest. Let's say our original principal was $10,000. So first 6 months, you will be charged 10% times 10,000. That's $1,000. That's going to be added to principal. So at the end of 6 months, you're going to owe $11,000. Now for the second 6 months, charge 10% to $11,000, and that's equal to 1,100. You can calculate that yourself. That means what you are due at the end of 1 year is 11,000 plus 1,100, and that's 12,100. Now, so total interest paid in a year is equal to 2,100. Well, that means total interest as a percentage of principal is equal to 2,100 divided by $10,000. That is precisely 21%. This rate is sometimes known as the effective annual rate, because if you have a loan that makes you pay 20% APR on a semi-annual basis, that means every 6 months you're paying 10%, but in the second 6 months, you are also paying 10% of the original 10%, which is 1%. This is known as the effective annual rate. Not annual. Or year. We can easily go back and forth between them, and we also have Excel formulas that will calculate them. In the next video, I'm going to show you how to do that in Excel using a little template that we're going to build. First, let's write down the formulas and end this small video. Effective annual rate is 1 plus APR divided by F, which is the frequency, raised to the power F minus 1. In fact, the whole thing, parentheses, minus 1. And APR is slightly more complicated. Come on, eraser. APR is 1 plus effective annual rate raised to the power 1 over f minus 1 and the whole thing multiplied by f. I know these are ugly formulas, but in Excel, we're going to have a nice little way of doing it. In Excel formula, effective annual rate equals, you use the function effect. I'm horrible using the eraser on this thing. In fact, let me write it with a slightly different color. And it has two arguments. The first argument is the APR. The second argument is how many days are in a year. And for APR, the name of the function we have is nominal. The first argument is effective annual rate. The second argument is frequency or number of periods in a year. I'm going to end this video here. This was just the introduction of the idea of APR and effective annual rate or year. And this looks like this is an ARR. No, we want to say APR. And to understand the difference between them. When you're comparing two loans that are otherwise identical, but they have different compounding frequencies, you need to use the effective annual rate to make a comparison. Because APR by itself doesn't say anything. You may have two loans. One of them has an APR that is greater than the other, but you may still prefer the loan that has a higher APR. We will do examples of that when we're implementing these in Excel.